and I am a PhD student at the University of Kentucky. In this presentation, I'm going to talk about a method to calculate the in-depth penetration of radiative heating in thermal protection system. Whenever a space vehicle is entering another planet, it enters at a very high Mach number. That number is anywhere between 35 to 40. At such high Mach numbers, the temperature across the shock layer goes up to 15,000 Kelvin, and at such high temperatures, the gases in the atmosphere get heated and reach an excited state. Ultimately, when the gases come to a ground state, they release some energy. This energy is essentially photons, and these photons travel into the thermal protection system. We are trying to understand how deep is the penetration of these photons into the thermal protection system. To do this, we have a microscopic approach and a macroscopic approach. In the microscopic approach, we are developing a scalable Monte Carlo radiation solver. In this, we essentially implement a ray tracing procedure, and we have and the material under consideration is Li900. Li900 is essentially a thermal protection system material, and Li900 is the formal name. The chemical composition of Li900 is silicon dioxide, and the composition essentially consists of a fibrous network of infinitely long fibers. It has a diameter of 5 micron with a porosity of 94% with a standard deviation. Another important concept, a concept of data that we need for this Sparta RMC code, is the refractive index of the host medium and the material under consideration. To determine the probabilities of absorption, extinction, and scattering, the principles of quantum and classical mechanics are implemented. Next, we have compared the results with the works of Joshua Marshall, which is given in reference to. With confidence in the results, we move to our next step to generate the optical properties and solve the radiative transport equation. Now, one major thing for this microscopic approach is we need the optical properties to solve the radiative transport equation, because these optical properties serve as an input to the RTE, which is the radiative transport equation, and solving that is our next step, and that essentially helps us in determining the depth of these photons. Thank you.